Now let's take a look at some other properties of subspace. So we have theorem 2. Theorem 2 means if we have, let's see, okay, let's just write down this briefly. If the subset only has 0 vector, okay, and this is a subspace of the vector space V. And in this case, actually, S is called the trivial subspace. S is called trivial subspace. Let's do the proof. It's pretty easy. So if we pick two vectors, and because they both belong to S, and the S has only one vector, which is 0 vector, and if we add them together, it's also going to be 0. And k times 0 is also 0 vector. So they both belongs to S. So S is subspace. Right, now let's take a look at another theorem 3. So the solution set. Let's take a look at the solution set to the homogeneous. Okay, I can write down a little more just in case you forget the definition. It's called a homogeneous linear system. That means linear system is AX equals B, right? If the right side equals 0, so if we make this equal 0, that means homogeneous. So it should be like this. AX equals 0 is a subspace. Of Cn. Okay. Let's write down the set notation firstly. What is set notation? S means all the vector, so it should be solution set. We can write down X. X belongs to Cn. Okay, and X satisfy what? Satisfy AX equals 0. So this is the set notation, solution set, right? We next want to prove this is a subspace. So we pick any two vectors in S. So we say we can pick. So for any X and Y belongs to S, that means what? AX equals 0. AY is also 0 because they are all solutions. And we test it. This one belongs to S. This one belongs to S or not, right? So they belongs to S or not means they are all solution or not. So we want to see, are they solutions? This equals what? AX plus AY, which is 0 plus 0, which is also 0. So we notice the X plus Y is also solution. So X plus Y also belongs to S, because AX plus Y equals 0, right? Next thing, we want to see scalar multiplication, which is K. AX is K times 0 vector, which is K. So, sorry, this equals K times any times 0, so it could be 0. Think of this 0 vector as like a column vector, linear system. So right side, this is AX, the right side all zeros. K times that is also going to be 0. So that means Kx also belongs to S. So S is a subspace. Yes. Okay. We have a definition. That means all the solution to the homogeneous linear system is called a null space because it's already subspace, right? So it just means the subspace in the last theorem is called a null space. So the solution set to the homogeneous linear system is called null. Null means 0 usually. Called the null space of A. And is denoted by this one. Now space A. So what's the meaning of this null space? Actually, that means, okay, write down one more space, one more time. Null space of A means all the vector belongs to Cn with condition Ax equals 0, homogeneous, Ax 0. Let's take a look at the example. Exercise. Let's see. Example number, let's see, 5. Determine the null space of the given matrix A. Okay, null space of given matrix A. So let's write down A as what? So it's kind of like we are solving for this. Is that right? There are two ways. Okay, you can write down, okay, A is given, A is like this one. So firstly, I should give you A. So we are solving for homogeneous linear system. You can write down like this way: 4, -7, -2, -3, 4, and the right side of the rows do the Gaussian elimination. So let's solve this. So I skip the detail, row operations. I just give this to you, and you should get similar thing. And for this matrix, we are going to get a 0 column, a 0 row, 0. So from here, let's see how to write down solution. x1, x2, they all have leading 1. So the free variable is x3. We can say t. So x3 is t. What is x2? x2 should be 60. And what is x1? x1 equals 2x2 minus t. So it should be 2, 6t minus t should be 11t. Is that right? So it's just like a soft linear system, but just the right side is of zeros. So write down the solution. Solution should be x1, x2, x3. So let's write down the null space in set notation, which means all the x belongs to Cn, and the x has which kind of form? 11t, 6t, and the t. And the t can be any c. So here just belongs to c. Okay, that means they can be the not real solution, maybe the complex solution. So this is the example. Here is the summary for this class, for this section. Okay, the first thing we need to know what's the meaning of subspace. It's a subset that satisfies two conditions. Any two vector belongs to S, and the scalar multiplication also belongs to S. So it means S is closer under those two operations, subspace. And for some certain, like a given set, we need to know how to prove is subspace or not. Second thing we need to know is the set notation. Think about the example we have. If S equals this kind of set, V belongs to R2, and all the vector equals this kind of form like X and 2X, for example, and the X can be anything. All S can be like a matrix belongs to M, N, R, for example, and A is symmetric. Think about those, right? So they are all set notations. And number 3, we need to know what the meaning of null space. Null space means the solution. Okay, solution satisfy of the homogeneous linear system, the solution set. That's the null space. So we just need to solve AX equals 0 and find the solution set. That's the definition. So also determine. We need to know how to find null space. Okay, that's all we need to know in this section. We can stop here.